Hi, my name is Siddhant Kafle, and for my final project, I worked on predicting life expectancy and determining factors that influence it. The motivation behind choosing this topic was we are all living in a global pandemic that has claimed the lives of many people, including our loved ones. This has inspired me to look at what are some habits and socioeconomic factors that influence life expectancy, and what are things that we can do as individuals and society at large to live a healthier life and have higher life expectancies. The dataset that I used for my project, I got it from Kaggle, and it is a merged dataset of national life expectancy and corresponding economic data from GHO and UNESCO for 183 different countries. I used this dataset to determine what habits and socioeconomic factors influence life expectancy and use those factors to predict life expectancy. For related work, I looked at a work created by M. Matson, who's the one who created this dataset on Kaggle. He also created a notebook that explored, cleaned, and then modeled this dataset using various machine learning models. And the main resource that I got from his work was at the top of his notebook, he explained the meaning of each of the columns, and he also had the full acronyms, full form names of the column names. So that was really helpful in understanding my dataset. I also looked at another related work created by Daria Vasileva, where she merged the life expectancy data with ecological footprint, human freedom score, and happiness data to analyze what factors contribute most towards happiness levels. And although I didn't directly use her work, her work could be used as a future work, as a build up for my work, whereby I can in the future mix life expectancy data with the happiness score and look at how life expectancy affects happiness. So the data was collected from Kaggle, and the data consists of life expectancy from 2000 to 2016. The dataset consists of 3,111 rows and 32 columns. For exploratory data analysis and data cleaning, I followed some sort of a cycle where I performed data cleaning, did some exploration, and again performed data cleaning on it. To begin with, I firstly used conditional indexing to remove unwanted columns, and I also removed columns that were 70% empty. For the remaining columns, I replaced the missing values with average value of their respective columns. Then I performed some EDA, where I firstly looked at how life expectancy changed over the years for every region. And as you can see, the life expectancy gradually increases from 2000 to 2016 for every region. I also looked at the distribution of life expectancy. As you can see, there might be a slightly right skewed distribution, and I'm not sure how I could go about creating a much more normal distribution. I'd be really grateful if Professor Nick Cheney could give me feedback on how I could make this distribution a bit more normal if this is a little right skew. But I also feel like it might have a normal distribution, so I'm really not sure on this issue. I'd be really grateful if Professor Nick Cheney could clarify on whether this is slightly right skewed or if it's a normal distribution. And if it's slightly right skewed, I'd be grateful if you could give me some suggestions on how I could make this distribution much more normal. I also created a heat map to look at the correlation between different features and our target feature. And some of the features, such as adult mortality and infant mortality, were highly negatively correlated with life expectancy, whereas things like basic water and obesity were positively correlated with life expectancy. After looking at the heat maps, I did some more data cleaning, whereby I deleted some of the duplicate or similar columns. Since our data set is a merging of UNESCO's data and GHO data, there were some columns that were repeating, such as the gross national income, life expectancy, and infant mortality rate. And I removed the data from UNESCO for these three values, and that way I had only one set of values. After that, I performed some more EDA, whereby I looked at life expectancy versus infant mortality rate. Here you can see clearly a negative correlationship. Over here, you can see a positive correlationship between life expectancy and access to basic water services. And I also looked at life expectancy versus general government health expenditure, and here you can see a slightly weak positive correlation between the two features. Before I moved on with data modeling, I did some data processing, whereby I converted some of the country code from string to integer data type by using the pandas factorize method. And I didn't include any categorical features when processing data to fit the linear regression model. And before modeling, I normalized the data. For data modeling, I used three different multiple linear regression models. For the first multiple linear regression model, I used all of the features, and after that, I used the COEF method to look at feature importance, and then I used some of the most important features to create another multiple regression model that predicts life expectancy. And finally, I also created a simple linear regression model that only uses the most important feature, and I compared these three models using the validation errors for each model. I used the root mean square error to calculate the training and validation error for all three models. For the first multiple regression model that uses all of the features, this is the residual plot that I got. I got a training error of 0.122 and validation error of 0.1222. I'm not sure why I'm getting the same training error and validation error for all three of my machine learning models. I'd be really grateful if Professor Nick Cheney could give me some more feedback and clarity as to why this is happening. I tried changing the different test and validation sizes, but the training error and validation error still seems to output the same result. And I'm really not sure how to fix this issue, and I'd be grateful if Professor Nick Cheney could provide me some clarification as to why this is happening and how I could go about fixing this issue. After looking for feature importance, these were some of the most important features: basic water, domestic government health expenditure, age 5 to 19 obesity, adult mortality rate, polio rate, and age 5 to 19 thinness. So I used these six important features, and I created another multiple regression model only using those features to predict life expectancy, and these are the results that I got. This is the residual plot of of the model, and the training error that I got was 0.206 and validation error was 0.206. Here again, I'm not sure why I'm having the same training error and validation error, and I'd be grateful if Professor Nick Cheney could clarify on this issue. But comparing the validation error with my previous model, you could see that the previous model performed better. And finally, I also tried creating a very simple linear regression model only using the most important feature, which was basic water, and this is the residual plot that I got. My training error and validation error for this simple linear regression model was 0.565 for each, and comparing these to all three models, the first model performed the best when we compared the validation errors. Conclusion: from this project, we can conclude that the multiple regression model that I created using all of the features was better and more accurate at predicting life expectancy. Also, access to basic water services seems to be the most important feature when predicting life expectancy. And my model performs as good as the fancy models that were created by M. Mattson, where he used feature engineering and gradient boosting on his regression model to get a validation error of 1.19, whereas my validation error was 1.22, which is pretty similar, pretty close by, I'd say. And for future work, one of the possible future works that I'd do is collect more data from 2016 onwards, And since COVID started at 2020 onwards, it would be really great to see how COVID impacted global life expectancy by comparing the life expectancy from 2000 to 2016, and then from 2016 onwards, and seeing how COVID impacted the overall life expectancy around the world. Another possible future work is to merge happiness reports similar to what Daria Vasileva did, and then try to see how life expectancy affected happiness score, or how happiness affected life expectancy. And finally, I'd also like to try out other different machine learning models and try to see what machine learning model is best suited for predicting life expectancy. Thank you. Oh yeah, I'd be really grateful if Professor Nick Cheney could give me feedback on why I'm getting same training error and validation error, and how I could probably fix this issue. And I'd also be really grateful if you could clarify on whether this is slightly right skewed or if it is normally distributed. Um, and if it is slightly right skewed, then I'd be grateful if you could give me some suggestions on how I could make this life expectancy data much more normally distributed. Thank you.